okay, in Java. In C++, strings are mutable. So a string is like a dynamic array of cards that you can't change. Java has this library called string buffer. I think of both string buffer and string builder. One is used in multi-threaded environments because it's synchronized, so it has a locking mechanism. I think, I'm not a Java guy, so somebody can research that after. But a string builder buffer is basically the dynamic version of a string. Strings are important. You use them every day. Now you gotta learn how to work with them, strings. So, I guess since we're just making this class about doing problems and learning as we do problems, we'll start with a simple one. Reverse a string. Reverse a string. See, what makes this annoying is that Java doesn't have an in-place swap function, so you have to make one yourself. But it's like 3 lines. So if we have string reverse, it takes in a string x public. Okay. Anyone know how to reverse a string?
What was that?
Does anyone know how to reverse a string?
You just pop it off the end and put it on the front instead of like for the length of the array.
What would be the runtime complexity of what you just said? If my string is constant.
And
Yeah.
that's bad.
No, that's fine. I mean, I don't
It's
know.
like you're like, no, I can do that log in.
No, I don't know if you can do it in anything less than
And
all of it. Like, I think if you can, they might hire you on the spot. I'm trying to think, like, but space-wise, what's the complexity?
That's linear.
It's linear space.
Yeah.
Why would you do that? You're making, so with what you're saying,
yeah, okay.
is you're making a constant character array every time you do that. Nonsense.
I thought you were using the same string.
So for what he just said, he wants to pop off the end and put on the beginning. So you're erasing and inserting.
Yeah.
That's making a string every single time. Feel me? Not good. They'll flame you on the spot. They'll be like, oh word, let's just walk them out now.
Alright.
For this, in place. How can we do it in place? Constant space, whatever.
just
Swap what?
the first and last.
The first and last? Is that it? Just the first and
The
last?
first and last.
You
and
say
then
like
keep going.
continuous.
And you keep going down.
Yeah. Until you reach the same.
How would you do that? Anybody want to do this? Come on, it's simple. Somebody code this. Somebody code this. Come on now. Y'all want to do
Come
this?
on, man. You
Yeah,
said it. You
yeah.
thought about it.
Yeah. I'm nervous. It's literally
Come
works.
on, man.
Like, yo, we here. We here to learn. Why y'all
I'll do
nervous?
it in Python.
Oh, nah.
Hey.
In Java. If I gotta struggle and I gotta hear about it from YouTube commenters, nah. Everybody gonna hear about it. Java.
So you gotta
Fuck it.
loop through, take that first one.
Java. Come suffer.
I'll try.
Yeah. Oh, let me take the C. Ooh.
Alright, so to like it's down equals 0. It's that line? Okay.
Yeah.
X dot line.
While
Yeah,
L is,
while, yeah.
while L is, while.
Listen, I'm giving myself room for fuckery. Alright? He say,
So what's the first thing you want to do?
You need
X.
temp variable.
Yeah, X.
Oh.
What is that? X.
Something at
L equals X R.
Where's your temp variable? Because you just lost that character.
Change.
You need to store the
You need to
state.
store the state of the one you're about to replace. Otherwise, how you gonna fill it in later? How are you swapping it out?
Mmm. You might have keys. Yeah, you might have keys.
Yeah, this shit is like. You're right. Alright, let's say L equals.
What is old L? What is the type?
It's integer.
It's a car.
Oh yeah, it is. Facts.
So my numbers.
Car, fucking X. Oh, tweaking.
Is that this Java? It's not called it.
Car equals.
So a string is an array of characters. So if you index something in a string, like x of 0,
Yeah,
character at that index. So if I said hello, that's H, E, L, L, O. So, okay, if you say x is equal to hello, x of 0 is equal to H.
So what language?
This is Java. Yeah, isn't it like,
You have to do
X dot
like
car.
string the current form.
yeah, and
What am I
that's C++.
doing?
I don't know what you're doing.
Shh.
I'm just trying to let him walk through it.
Yeah.
Then we can correct the syntax.
X. L. O.
This is X dot car.
O. L. O. R.
And then X.
R.
That's why he doing stuff in the
Don't forget to increment your stuff.
Word up.
Indefinite.
She might be nice.
Oh, no, you gotta edit it.
You
Alright.
gotta increment indefinite.
Yeah. Yeah. It's facts. Right?
Yeah. You got extra stuff. You should be good.
You said it was an extra step?
Yeah. You don't need a temp variable for one of them.
Oh, you said I did an extra step.
Yeah.
Yeah, that's facts. Is it a bad way of doing it? Because I feel like that's not constant time. It's still linear.
No,
That's constant time?
that's good. Yeah, we just gotta change the syntax of it for Java syntax. So Java syntax is different. C++ is more. That would be how you would index it, you do a swap and whatnot. But Java is a little different. You gotta convert it to a character array and then you do the swap
You
later.
gotta. That's too much work.
That's what we got. Got the keys.
Fail.
I'm a defensive end when I play. Did not catch.
Excuses.
So, logically, and why algorithms are language agnostic, this works. Take the old L, take the old R, set it equal to that, set it equal to that, plus minus minus. Perfect. L is less than R. Perfect. Okay? Now we gotta write it for
How
Java.
is that constant time?
It's not constant time.
Oh, that's what I'm
It's
saying.
linear time. It's constant space.
It's semi-regular.
It's the same array.
Oh, you mean like, okay, got you. It's not copying and creating a new one. Okay, got you.
So when you do runtime analysis of your function, it's always the actual runtime, which is like the algorithm runtime, and then it's the space. If you're making any new spaces to do anything else or whatever. This is in place. Right, you're just swapping. These don't count as space. I know some people would be crazy. That isn't, a variable is not space. It is.
How do you get the constant space time anyway? How do you calculate that?
Huh?
How do you calculate that constant space time?
Constant space?
Mm,
Are you making a new array?
No,
Are you making a new string?
no,
In place.
okay.
Constant space.
But you're saying arrays are not space because basically because it doesn't matter most of the time. Like
What do you mean?
like making variables isn't considered like space. Is what you're
No, it's a
saying.
variable. Like, what
It's
can
an
you do?
all one thing, so it's not gonna.
If you can solve a lot of these problems without making a variable, you gotta get hired. Like, I don't know how you gonna do that. Like, you need some way to store state. So, alright, so just to translate this for Java people, it would be Somebody can check this for me if it's a constant character. I don't know if Java makes it constant or just a character. I forgot. Let me see, 4. Well, actually, this would be constant because it's right. So, 9 plus plus. And then we say, what do you do? We say car temp is equal to, say, array of R length minus 1 minus I is equal to, sorry, reverse that. This is equal to R by is equal to that, and R of minus 1 minus I is equal to return R dot 2. I think that's the syntax. I'll put it in the code pad to make sure like that's the right syntax and it compiles when he sends it out. But I think that's right. In terms of like the Java way, car temp is RY. So we say RY, we change it to the end. I dot length minus 1 minus I is equal to 10. Turn R dot string. I think that works. Does anyone get this? The length minus 1 minus I.
Yeah,
Want me to walk you through? Cool. So let's say our string is hello. So x is equal to hello. Right? And now we're converting it into an array. So we say array is equal to h e L, L, O, right? So now our hello is an array. Now, what I'm doing is temp is equal to R of I, right? R of I is 0, our first iteration. So we say temp is equal to H. Now we're saying R of I, which is H, we want to set equal to the length of the array. So hello is what? 5, right? 5 minus 1 gives you the last value, minus I, which is 4. So our index 4 is the O. So the H is now equal to this O. And then we say the last one set equal to the temp. So the O is now equal to H. So our array, after our first loop, is going to look like O, E, L, L, H. Okay? Did everyone follow?
1 second, so array.length minus 1 minus I.
Yeah.
So array.length minus 1 is O, right?
Yes.
Then,
I is 0. When the array first starts, I is equal to 0. Okay? So after our first iteration, this is what our array is now going to look like. So now we go, and I is equal to 1. Right? So what's R of 1? What's R of 1? E. So temp is now going to be equal to the E. Right? And R dot length is still 5. Minus 1 is 4. I is now equal to 1. So 4 minus 1 is 3. What's the 3? The L. And then we swap. And it keeps going down until, sorry. That's why you always test.
You idea?
Divide by 2.
Oh, fine.
If you keep going, it's just gonna swap. Okay? So that's how you reverse a string. We got this time. We need to keep that.
no.
Oh, alright, straight. So yeah. Divide by 2. If this kept going, like if we just put it as array.length, right? Eventually, let's say I is now equal to 4, which is less than the length, right? The last index. This would say R of 4 is equal to 4 minus, sorry, R of 4 is the last index, yeah, right? That's 4 minus 1 is 3, minus 4 is, yeah, negative 1. Make sure it closes up. R is maybe it just doesn't work if I don't do divide by 2. Let me check. This is 0. This is 4. Minus 1. Minus 4. Minus. Sorry, it's 5. 5 minus 1 minus 4. Yeah, okay. I'm an idiot. Yeah, it'll just swap. It'll keep swapping. So if I go past this pivot point, so 5 is the length, 5 divided by 2 is 2. Into the division on down. If I go past this point, it's just going to swap again. Because it'll go swap, swap. It'll leave this, and then it'll go back again. So then it'll swap again and swap again. So we want to stop it. Surprisingly, that's still linear time. Even though you're only going through half the array, it's still linear time. Because you're not, for it to be logarithmic in time, you have to be halving the problem at each step. Do you get it? You're not halving it at each step. You're just going to half. So, a little bit of a quirky thing, but when you start to like get into algorithm complexity, it'll come like that. Cool. So I think it's what is it? It's 8:30.
You're getting there if you like.
I mean, if you guys want to do one more, that's fine. I got like 400 problems under my belt. A lot of those y'all not ready for yet. I'll be honest with you, they can get up there. And when you go to the Google interview, you'll be like, yeah, it's the hardest one, and you gotta solve it in like 5 minutes. So, life hard. But if y'all want to do one more, I got one more string. Oh, cool. Okay. Don't think you guys are ready for this one. What I was gonna put was like reverse the words in the sentence, but I don't think like that needs a little bit more practice.
How do you separate like spaces?
Yes. Yes. You separate it by the spaces and you would reverse each one. No. So what you would do is a little bit more complex.
Turn it into an array.
Yeah.
You turn it into the array, reverse the whole array, then reverse each word that has a space. Sounds intricate, but
That sounds
Do
right.
it, run through it.
This is to do it.
sounds good. Okay. So let's say our sentence was x is equal to split. Right? So how the algorithm would work, how you think about it to start getting into this world, was first, you know at some point you're reversing something. At least this is how I start to think about algorithms. It says reverse the words in the string, so you know you're going to be reversing something. Right? So I would make a reverse function that just goes from the start to the end point and reverses whatever I gave it. Okay? But I'll put that on the code pad. But for now, just to walk through it visually, how it would work is that I reverse this whole sentence. Does this work? All right, real quick. You know you gotta go on. Reverse it. Oh,
You ain't playing the game.
yeah, it's over. Mom. Yeah, I'm teaching right now. Can you give me 5 minutes? All right. Back to work. So you reverse the whole string, right? So it'd be TTIL space STI. Right? Then you reverse each word. LITT SIT. Oh, sorry. ITS.
Question, why would you?
How would you think about this?
No, I'm saying, why thought you did extra word?
What do you mean?
Why not just, instead of like reversing the words?
Just turn it into an array by the split of this and then do that?
Yeah.
A follow-up to the question would be if you went to like a Google interview, don't split the array. Like you can't.
So you're not allowed to theorize,
Yeah.
so what would you do?
Or they might say do it in place.
Okay.
Wait, say that one more time?
So if I made this into, okay, Java you have to make it into a character array, right?
Mm-hmm.
But a Google interview would just probably give you a character array. in order to do what she's saying, I would have to make another array.
No, well, I get what you're saying, but I meant to repeat your solution.
My solution? My solution is in place, right? So taking the same string, you reverse the whole string. So this is what it would look like reversed. Then I would loop through the string, keeping an offset pointer or a beginning pointer, which would be equal to the first character, which would be L. And I would loop until I hit a space. And then I would reverse
Everything between your offset
between that.
space.
Yeah. Then I will now set my offset to +1 of where the space is at. And I keep going until I hit another space until it reaches the end. This way I know at the end, I'm always gonna do that last reverse. And then my whole thing is done. And this is in place. So it's O of n time over one space. Rather than doing it that way, it's still O of n time, but you're using more space. So it's O of n space. Because now you have to make a string array. So you do like string r is equal to x dot 2. Oh yeah, I'm getting nice with the Java. 2 array facts dot split. Okay. Of the car space. And then this would tokenize it, and then you loop through the thing and just reverse it like you normally do. But this is making space. The thing you want to know when you're trying to think of these solutions to problems, you always want to try and think of the best case for what you can think of in that moment. Okay? There are certain occasions when you might know the best case, but you might not know how to fully program it. Go to the one before it then. And then hopefully an interviewer might give you a hint to help you along that path. A good example of that would be this one or the two-sum, whatever, where you would put the brute force, and then, because you can't think of it yet, and then maybe your interviewer would put that equation in the board and tell you to solve that, and then you go from there. Like, that's usually how programming interviews work, unless you have a jerk, an interviewer. They'll just sit there in silence, and you just be like, oh, you know, I tried. Yeah. So, I don't know what you got planned for next time, but we'll keep the algorithm simple for about the next 2 to 3 weeks. And then we'll start getting into a few higher level ones. And then toward the end, you know what I'm saying, y'all gonna be using DFS and backtracking algorithms. So you're gonna walk into the interview, he's like, yeah, I'm ready. What you gonna do?
You think next couple of weeks we should just do that shit through like video chat? Make it easier for everyone because I don't know, during the holidays and all that other shit, it might spit off. People actually like come somewhere.
That's up to you. I don't really care. I mean, we have the coder pad. Like, coder pad allows people to type, C as you type, and compile.
Alright,
So that's why, like, I really don't, doesn't matter.
Yeah.